It's totally unstable. It's going to explode. No, giving me will not be a surprise. An open door to go for that. The thing is, it might be tomorrow. It might be during this transmission. What's more, it would glimmer like a subsequent sun over the James Webb Telescope. As of late, it has perceived an astounding 250% expansion in the wonder of appalling, crawly, Jew, the red star found at the shoulder of the Orion star grouping. This capricious conduct has lighted energy for an enamoring include. Some propose the unanticipated development in wonder could show that Betelgeuse is intending to go supernova. However, the specific timing remains problematic. Experts measure it could occur after a short time. Join us as we examine the profundities of space and unravel the insider facts encompassing this wonderful Goliath. Bug juice can possibly reshape how we comprehend the universe. No matter what its name not being well known, you've most likely taken note of its magnificence, a stunning blushing sparkle communicating at the shoulder of Orion, a perceptible star bunch. Bug juice's size is wavering. At whatever point set at the middle of our planetary framework, its external surface would stretch out past Jupiter's circle. This monster star, easily noticeable, continues to beguile us. Not at all like most stars, Bug juice shifts in magnificence over time. In view of its area to our framework, known as a semi-normal variable star, it blends changes every so often, showing a potential devastating breakdown in a grandiose blast. As of late, Bug juice has become altogether more amazing because of shocking changes in splendor. These progressions include a critical flood on May 20, 2023, when scientists observed a confounding 142% addition in quality, followed by a later update showing a 150% extension. Andrea Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, takes note of that Betelgeuse at present positions as the seventh most splendid star in the night sky, climbing 3 spots from its standard T-spot. From the southern half of the globe, scarab juice sparkles brilliantly at the night sky, easily apparent at the shoulder of the Orion heavenly body. Dr. Sarah Webb, an astrophysicist from Swinburne College of Technology in Australia, underlines bug juice's importance. It offers a dazzling, amazing chance to concentrate on the last phase of a gigantic star's life, giving critical experiences into the way of behaving of red giants before they explode as supernovae. When bug juice ultimately explodes, it could turn out to be inconceivably brilliant for around 7 days, potentially making shadows around nighttime. This prospect has both novice stargazers and master cosmologists anxiously expecting the occasion. Heidi Morris, a specialist at Los Alamos National Lab and leader of the Padaro Space Researchers and Cosmology Club, highlights the enduring interest in Betelgeuse's splendor changes, a phenomenon long neglected by other societies. Presently, Betelgeuse's brilliance cycle goes on around 130 days, a lot more limited than its typical multi-day cycle. These quick changes offer stargazers an extraordinary open door to concentrate on this heavenly peculiarity in detail, revealing more about the last phases of a star's life. The bizarre conduct of scarab juice started in 2019, at the point when it violently catapulted a piece of its external environment. These progressions in splendor are remarkable for insect juice, lighting theories about whether it will soon detonate into a supernova. As per a paper by Dupree and different analysts from Harvard and the University of California, Berkeley, it will take another 5 to 10 years before Betelgeuse returns to its generally expected 400-day splendor cycle, as its light and outward speed conduct have changed. In spite of its inconsistent conduct, bug juice stays a gigantic red, very giant star going through the last phases of fast advancement. As it depletes its fuel, the center will ultimately fall under its monstrous mass, coming about in an epic blast that might actually obscure whole cosmic systems. The planning of this blast remains questionable, as made sense of by Dr. Doc, a teacher of stargazing at the University of Portsmouth. Anticipating galactic blast occasions is testing because of the restricted verifiable information and the intricacy of heavenly development. Bug juice is right now going through combination processes, continually developing through components like helium, carbon, oxygen, silicon, and iron. As a red giant star, it wires helium into carbon at its center, an interaction that requires a long period of time. At last, it will advance to intertwine heavier components until it can never again support combination responses, prompting gravitational breakdown and conceivably framing a black hole or neutron star. While some estimate about Scarabjuice's approaching blast, verifiable records show that it has been developing red over the recent years, proposing that it might take significant time before it goes supernova. NASA assesses that Scarabjuice isn't supposed to detonate for an additional 100,000 years, offering solace that its impact is probably not going to occur within our lifetimes. Regardless of the vulnerabilities in Betelgeuse's behavior, its progressions continue to enamor specialists and move advances in our comprehension of heavenly development. Dr. Sarah Webb reminds us to remain open to all possibilities, even as we recognize that the likelihood of seeing Betelgeuse's blast in our lifetimes is thin. Following its progressions may lead to further logical leap forwards, permitting us to keep hope alive for new revelations in the universe. Recalling that it's huge, our perceptions of insect juice are basically looks into the past. The light we see from the star is more than 600 years old, meaning bug juice may have proactively detonated and we wouldn't yet know it. While this probability exists, it remains questionable. History has shown that our suspicions in space science can be tested. Previously, in 1987, stargazers trusted that only red supergiants could go supernova. However, in that year, an enormous blue star in another world exploded, stunning the academic community. There is still a lot to learn, and surprises might lie ahead. Noticing bug juice and other huge stars permits us to grow our comprehension of divine peculiarities. No matter the absence of an approaching blast, Betelgeuse's continuous conduct remains spellbinding. Its progressions, both diminishing and lighting up, reveal interesting physical science. The way that stars advance on human timescales is momentous. While creepy crawly juice is presently a lot more splendid than anticipated, because of its sporadic multi-day cycle, there is hope it will ultimately return to this cycle. Anyway, later observations suggest that bug juice might be in its last stages, switching up the finish of its center carbon-consuming cycle. This stage involves the change of carbon into heavier components like oxygen and magnesium. Provided that this is true, specialists expect a center breakdown, prompting a supernova that could occur within a couple of years. By and by, the specific phase of Betelgeuse's advancement remains testing to decide, and vulnerabilities continue. The opportunity of seeing insect juice's blast remains indistinct, as the carbon-consuming stage can endure as long as 1,000 years, and the study proposing a looming influence has yet to be accepted for publication. In any case, the potential for scarab juice to turn into a supernova is invigorating. It would be an intriguing occasion, noticeable even during the day for a few days. When the blast at last happens, the early signs of the heavenly blast will be unobtrusive, but evident, with neutrinos clearing across Earth as high-energy photons escape from the extending haze of astronomical flotsam and jetsam. Bug juice will slowly develop more splendid in the night sky, maybe arriving at peak brilliance 10,000 to multiple times its not unexpected brilliance within the space of weeks. This occasion will astound anybody sufficiently fortunate to observe it, denoting a significant moment in history, inestimable history. The remainders of insect juice's blast could be as splendid as a quarter or a half of a full moon, stuffed into a solitary mark of light. Exceedingly, this brilliance would be noticeable during the daytime, making sensational shadows at night. Gauges recommend that scarab juice could become 15 to multiple times more splendid than Venus, currently the second most splendid object in the night sky. The show of bug juice's blast would last for something like 100 days, spellbinding space lovers and offering an extraordinary opportunity to witness the result up close. Luckily, Betelgeuse's cosmic explosion would represent no danger to humankind, as it is still far away. Telescopes and optical instruments would permit us to notice the event without harm. By and by, such a marvelous occasion wouldn't go unnoticed. Supernovae are often deciphered as unfavorable signs, and bug juice's end could incite captivating responses. Generally, space experts believe it could reignite broad interest in stargazing, arousing people to the marvels of the universe. Scarab juice doesn't seem to be the only red supergiant in our world. Others, like Edi Carni, could detonate before it does. Our Milky Way is expected to experience a cosmic explosion about once every 100 million years. Yet, we haven't seen one in the last 400 years. However, we've noticed the remainders of past blasts, showing that we're past due for a critical heavenly event. It's just a matter of time before the next star goes supernova and the universe pays heed. Betelgeuse's history is rich with outstanding events, including the sensational darkening in the fall of 2019. This sudden drop in brilliance astounded astronomers and started speculation about its potential blast. Despite the fact that Betelgeuse's brilliance returned to normal by April 2020, the cause of its darkening remained a mystery until further observations provided insights into the phenomenon. Skywatchers can easily spot scarab juice from their homes, making it an accessible cosmic object to engage with. If a cosmic explosion happens, it would undoubtedly give an incredible divine display. As we continue to monitor Betelgeuse, the star remains a focal point of interest for both expert cosmologists and amateur skywatchers alike. The continuous changes in its brilliance offer fascinating opportunities to study the cycles happening inside a dying star. With advanced technology, analysts can now examine Betelgeuse's behavior with remarkable accuracy. Instruments like the James Webb Space Telescope, along with ground-based observatories, are revealing more mysteries about this heavenly giant. The study of supernovae like the one scarab juice may eventually has extensive ramifications. Beyond understanding the last phases of a star's life, these blasts play a critical role in the creation of elements heavier than iron, which are essential for the formation of planets, life, and the very universe we live in. In many ways, the death of stars like Betelgeuse contributes to the building blocks of the universe, enabling new stars and planets to form from the remains of their exploded cores. Should Betelgeuse go supernova during our lifetime, it would offer a remarkable, once-in-a-lifetime opportunity to observe such an event up close. For those fortunate enough to witness it, the light from the blast would briefly outshine all other stars, becoming a distinct feature in our sky. As space specialists rush to capture the data, the event would fuel further advancements in space exploration, empowering more examination into heavenly development, vast explosions, and the mysteries of the universe. Despite when it happens, Betelgeuse's potential blast will be a crucial event for cosmology, expanding our understanding of how we interpret star death and the life patterns of massive stars. The explosion may also inspire future generations of cosmologists, igniting an interest in the universe and encouraging individuals to look in wonder at the vast universe. As specialists continue to observe Betelgeuse's behavior, the mysteries surrounding its life cycle and impending blast continue to spark interest across established researchers. One of the most captivating aspects of this star is its unpredictability. While numerous stars show regular patterns of brilliance, Betelgeuse is anything but typical. The changes in its light output are not only because of its usual variability, but also the violent activity occurring in its outer layers. These ejections, which remove material from the star's surface, are signs of its instability and add an extra layer of importance to its potential to become a supernova. Betelgeuse, formerly known as Betelgeuse, is one of the most well-known stars in our night sky. Its particular behavior has enthralled researchers and stargazers alike, leading to ongoing studies aimed at revealing the definitive fate of this massive red supergiant. However, its potential to detonate as a supernova might seem like a distant event. Betelgeuse's eccentricity has made it an intriguing subject of research. In fact, the star's peculiar conduct offers a rare insight into the life cycle of massive stars, providing significant information about processes that are generally hidden from view. One of the most important features of Betelgeuse is its location in the Orion constellation. It marks the left shoulder of the Hunter in this prominent star pattern, making it relatively easy to spot with the naked eye. This proximity to Earth, about 700 light-years away, gives researchers a unique opportunity to study a dying star in detail. While this distance is vast by human standards, it's relatively close on a cosmic scale, allowing us to observe its dramatic changes in brightness more closely than most stars. These fluctuations are a sign of Betelgeuse's status as a semi-regular variable star. Its light output changes over time, with periods of dramatic dimming and sudden increases in brightness. This kind of behavior isn't unprecedented among red supergiants, Yet Betelgeuse's erratic movements have drawn particular attention. Unlike other stars that have more predictable brightness patterns, Betelgeuse's irregularities suggest that something much more significant is happening inside the star's core. Astrophysicists have long speculated about the cause of these fluctuations. Some researchers believe that the star's instability is a sign of an impending supernova, while others point to the possibility of internal cycles, like magnetic fields or mass eruptions, causing the anomalies. Regardless of the exact cause, the unusualness of Betelgeuse's behavior continues to intrigue scientists. Each new variation in its brightness offers fresh insights that could bring us closer to understanding how massive stars evolve before their catastrophic deaths. Curiously, despite these unusual fluctuations, Betelgeuse's eventual supernova remains a subject of debate. While some analysts argue that the star could detonate within the next few thousand years, others suggest that the event could be much further off. In fact, some astronomers predict that Betelgeuse might continue its erratic behavior for as long as 100,000 years before it goes supernova. This uncertainty arises from the fact that predicting the death of stars, especially ones as massive and unpredictable as Betelgeuse, is a complex and challenging task. Moreover, the blast of Betelgeuse could have extensive implications for the study of heavenly death. A supernova in our galaxy, particularly one as close as Betelgeuse, would offer stargazers a once-in-a-lifetime opportunity to observe the death of a star in unprecedented detail. Such an event would not only provide a deeper understanding of how stars like Betelgeuse evolve, but also shed light on the broader cycles that govern the life cycle of the universe itself. Ultimately, the mystery surrounding Betelgeuse has the potential to reignite interest in space exploration. As researchers continue to monitor the star's fluctuations, the public's interest in this cosmic phenomenon will likely continue to grow. The prospect of witnessing such a rare and awe-inspiring event could rekindle a global fascination with stargazing, inspiring future generations of scientists and space enthusiasts to explore the vast unknown. Whether Betelgeuse detonates in the course of our lifetimes or not, the star's ongoing mysteries will undoubtedly continue to captivate both scientists and the general public alike.